Welcome to another workshop. For today, we have Gabriel from Evangelist. So I'll let him take it away.
Excellent. Thank you so much, Birdie. Hey, everybody. This is Gabriel. My name is Gabriel Cardona, and I'm developer evangelist at Avalabs. And I just want to first give a shout out to the Moralis crew. Thank you so much. It has truly been a pleasure working with you guys so far. Very professional and very competent team. It's been great. And then, as I mentioned, I'm from Avalabs. So, of course, I just always want to give a shout out to Avalabs. So much love and professionalism from that team as well. So today, we wanted to give a high-level overview of the Avalanche Developer Toolkit. And so basically, this includes different libraries or different services which are available to you as a developer in the Avalanche ecosystem. So I'm going to share my screen and give some slides here. Okay. So again, quick introduction about who I am. So as I mentioned, my name is Gabriel Cardona, and I am developer evangelist from Avalabs. And it is my very cool job and my honor to go around to hackathons and meetups and conferences and conventions and give presentations, hoping to inspire people to build amazing dapps on Avalanche. And I'm incredibly passionate about my job. I put a lot of energy into this, and I really believe in it. And why do I put so much energy into this? I believe that the most valuable asset on the planet at the current moment is a competent, hardworking, and creative developer. And so the reason I believe this is if you zoom out and you take the 10,000-foot view of where we are in the evolution of our species, I would say that we are just now beginning to see just a glimmer of the promise and the potential of humanity. There's so much that we have before us and so much we're capable of. But I also believe that we have, problems that we need to solve at scale and velocity. I think we're very fortunate in that, going back through the Industrial Revolution, there have been so many paradigm shifts in the fields of engineering and computer science, going all the way back. I like to go back to Ada Lovelace and Charles Babbage, the difference engine, the analytical engine. These were Victorian era, big, think like a steampunk computer. From then until now, we have had just this series of big paradigm shifts. And so we find ourselves with a toolkit that is unlike any time in all of human history. So what we need now are competent, creative, and hardworking people to, build the systems that solve the problems. And so I often say, there has never been a greater time in all of human history to have a big idea, to find a like-minded group of people, to raise capital, to launch a game-changing dapp, to change the world and to make a fortune. And the amount of capital, both human capital and financial capital, the amount of capital needed to launch a startup has been rapidly decreasing, and that's accelerating. And so if you look even 10 years ago, a startup that may have cost you $1 million to launch, 5 years ago may have cost, between $100,000 and $500,000 to launch. And now today you can launch that same startup for tens of thousands of dollars. And the reason is the software stacks and the APIs are becoming so powerful, and the economy of expression is so great that it simply just requires less engineers to write and maintain the systems. Think about Moralis is the perfect example. What you can do with the Ethereum boilerplate is amazing. There's basically like 90% of most of the dapps you're going to want to launch are already there. And the economy of expression with the APIs is so powerful that it only takes 1 or 2 people to write an amazing app when you're using Moralis and Avalanche. And then also all of the platforms are either open source or they have a free tier. And this brings the cost of shipping an MVP way down. You know, again, think about Moralis. Moralis has a free tier. You want to spin up a full node, an index, or all of that stuff, you can do it for free. So you can create your MVP for free. And then another huge innovation in Web3 is that Web3 has value as a native primitive, right? So it is in vogue today to raise capital via an ICO or yield farming. So it's in vogue to have tokenomics in your application and to create a token, which is a value-bearing asset and becomes worth money. And then there's also a lot of capital in the ecosystem in the sense that there are many, many successful blockchain entrepreneurs and investors that were successful from previous rounds of, you know, the history of the blockchain. There's people who made a lot of money in Bitcoin. There's people who made a lot of money in Ethereum. These people are also looking to invest capital, both ideas and, you know, financial capital. And so the story I like to tell to kind of draw the comparison before we dig into the tech a bit is when I was at Trulia in 2012, I worked at a place called Trulia. Trulia was acquired by Zillow for $2.5 billion. When I was there in 2012, we had an IPO. We went public on the New York Stock Exchange. And our CEO, Pete Flint, who is an absolute wizard, did a road show, went all across the United States and met with all kinds of bigwigs and pressed the flesh, you know, shook a bunch of hands. We had to hire an entire team of, you know, financial Silicon Valley lawyers. The entire process was basically wrapped in red tape and took around 13 months, if I remember correctly, to complete. And when we went public, we raised, we rang the bell on the New York Stock Exchange. We raised $102 million in that one day on that IPO. Now compare that with the process of creating a token on our C-Chain and launching an ICO or an IDO, an initial DEX offering on, you know, like at Avalanche, for example. You could raise $100 million in one afternoon. You know, $100 million is relatively a lot of money, but it's actually relatively not that much money. And there's the pace at which capital moves in Web3 is shocking. And you see it with something like this very hackathon. You know, first place is the minimum 100 grand, plus if you qualify for any of the bounties. I'm sure there have been plenty of startups which have started with less than 100 grand as an angel round. If you're doing a ramen startup, if you've got 2 or 3 people working with you and you're all engineers and you can ship the code and you're using open source software and you're all living together and you're eating ramen for every meal and you're using the free tiers and you're using the open source tooling, you can bootstrap a startup for 100 grand. Absolutely. And so the last reason that there's never been a better time to have a great idea and change the world is that everybody on the planet right now is super wired in, and ideas spread globally nearly instantly. And so the amount of time between the introduction of a new technology and the amount of time when it goes mainstream is decreasing. And, you know, you can think like, how long did it take for the telephone to go from one person to everybody in the world had a telephone? Now, how long did it take for the iPhone to go from one person and an iPhone to everybody had a mobile device, right? The pace of change is accelerating. And so we should expect to see this Web3 technology really, really accelerate, adopt at a very, very rapid pace. And that's what we're seeing. So now I kind of want to touch on some of the tooling that is in the AvalancheGo ecosystem. There's a bunch of different stuff here I'm going to touch on, and any one of these can be used to build applications. Some of them work together, some of them work solo, and we'll talk about that a little bit. But I think the first one we want to touch on, of course, is AvalancheGo. And so AvalancheGo is the full node implementation of the Avalanche protocol, and it's the reference implementation at this current moment. And that doesn't mean that we don't want alternative clients. We most certainly do. The way we view it is it's kind of like the World Wide Web. And, you know, there was a time back in the day where there was the web was divided into 2 camps, Netscape Navigator and Internet Explorer. And there were no DOM APIs. Everything was reverse engineered. And engineers would have to create 2 versions of every website, one that worked on Internet Explorer and one that worked on Netscape Navigator. And every website had a little banner at the top that said, this website works best in IE5, or this website works best in Netscape 4. And then I'm going to compress a bunch of events here together to compress the timeline. But Tim Berners-Lee, the gentleman that created the web, created the HTML5 working group at the W3C, the World Wide Web Consortium. And the HTML5 working group managed to get all of the browser vendors, Safari, Internet Explorer, Chrome, Opera, did I say Safari? Or Internet Explorer, yeah. So all of them on the Firefox, all on the same page, all 5 major vendors. And now we live in a world where there is a network, the web, and we have a standards body, the HTML5 working group, and then we have a standard, the HTML5 specification, and then each one of the browser vendors can implement it. And they all can be confident they're going to be on the same page. And when you write an app, it's going to run in each one of the browsers, but then they can also bring their own little special sauce, which allows them to compete in the marketplace. We would like to see the same thing with regards to full nodes, right? We would like to see some type of official standard or specification, and then multiple implementations of the standards, one of them in Golang, one of them in Rustling, one of them in C++. Some people may know that there was a full node written in Python back in the day before we launched the mainnet. There was AvalancheGo, which was called Gecko at the time, like the little lizard from Hawaii. Gecko, and then there was a Python client. And AvalancheGo was always a little bit ahead of the Python client, but the Python client almost made it to mainnet, almost. And now it hasn't had much love since the mainnet, so I suspect it's pretty far behind. But just for historical purposes, there was, in fact, a second client, a Python client, for a little bit. AvalancheGo, of course, since it's a full node, is it has the primary subnet, so it has the X chain, the P chain, and the C chain, so you can do everything you could do, in the Avalanche platform. Of course, you can do it here. You can create transactions, create assets, variable capped assets, fixed cap assets, non-fungible tokens. You can import and export assets across the different blockchains. You can add subnets. You can add validators and delegators. You can add subnet delegators and validators. You can launch blockchains. The full suite of APIs that are available on Avalanche as a platform are available through this particular body of software. And it also has a JSON RPC for doing everything. So, if you've dealt with, Ethereum or Bitcoin in the past, about a JSON RPC API. We have that, of course, extensively. A couple other things worth noting. There is a key store on here. We think it is a anti-pattern to store your keys on a full node, because if a hacker gets access to your machine, they're going to have access to your keys. However, it is, sort of the way these things work, that there's key stores on full nodes. So we have one. We suggest that you use something like AvalancheJS, where you can store your keys in the forms of mnemonics and sign transactions offline and that kind of thing. But again, there is a key store here that exists. And also, if you check on a Linux box, your home directory, / there's a hidden directory, .AvalancheGo. And in that directory, there are 3 directories: staking, DB, and logs. If you look in staking, you will find that there's a TLS certificate and a private key. And so something to realize there is that Avalanche uses transport layer security, TLS, to protect node-to-node communication from eavesdroppers. And TLS combines the practicality of public key cryptography with the efficiency of symmetric key cryptography. And this has resulted in TLS becoming the standard for internet communication. And whereas most classical consensus protocols employ public key cryptography to prove receipt of messages to third parties, the novel Snow consensus family, which is what Avalanche uses, does not require such proofs. And this enables Avalanche to employ TLS in authenticating stakers, and it eliminates the need for costly public key cryptography for signing network messages. So we have TLS certificates. We do not rely on any centralized third parties, and in particular, Avalanche does not use certificates which have been issued by third-party authenticators. All certificates used within the network layer to identify endpoints are self-signed, and this creates a self-sovereign identity layer. No third parties are ever involved. We also use TLS addresses. So to avoid posting the full TLS cert to the platform chain, we hash the certificate. And for consistency, we employ the same hashing mechanism for TLS certificates as Bitcoin uses. Namely, we take the DER representation of the certificate, we hash it with SHA-256, and the result is hashed with RIPE-MD160. And this gives us a 20-byte identifier for stakers. And we take that 20-byte identifier and we CB58 encode it. You may have heard base 58 check encoding in Bitcoin. We have what's called CB58. It's a base 58 encoding similar to base 58 check. The difference being that we only SHA-256 one time and Bitcoin does it twice. And we use the last 4 bytes for the checksum, and they use the first 4 bytes. So if you see CB58 in our documentation, that is CB58. It's similar to base 58 check, but there's a couple little gotchas there that are worth noting. So we take that CB58 encoded string and we prepend node ID to the beginning, and that's how you get your node ID. So once you have a full node up and running, what are you going to want to do with it? Well, you're going to want to run a local network. And if you're familiar with Ethereum, you know about Ganache. So I'm talking about something like Ganache. You may see here at the top, we are sunsetting Avalanche. It is true. If you've been around a long time, you know that we have a local development environment called Avalanche. The Ava shell, it's been around since the very, very, very beginning. It has served us well. But recently, we had already been brainstorming on Avalanche 2.0. And basically, the local network runner happened before that. So it was already that Avalanche was coming to the end of its usefulness, and we were going to be doing a 2.0 movement, and that just happened to be channeled into the local network runner, is what this is called, the LNR. And so this allows you to spin up a 5-node local network, and the nodes that compose the network can run either locally in the Kubernetes cluster, or they can, they can run locally, or they can run in a Kubernetes cluster. And if you run it locally, each node runs in a separate process on your computer. So, you know, you can spin up a 5-node network. It's 5 instances of AvalancheGo running in 5 separate processes. Or if you're running Kubernetes, each node runs in a Kubernetes pod. And the pods can, of course, be local, or they can be remote. And when you create a network, you specify the configurations of the nodes that are in the network upon creation. And you can create a custom AvalancheGo Genesis with a function called basically network.new AvalancheGo Genesis. So this is pretty cool. When you fire up the network, you can both script the configuration as well as a custom Genesis vertex or a custom Genesis block. That's obviously very cool. And then there's also default network creation. So as you can imagine, you know, spinning up multiple nodes on a network and configuring them could be tricky. And maybe it's not something you want to get bogged down with. So we have a default network creation. It has a helper function, new default network, which returns a network using a predefined configuration. So basically, this allows you to spin up a new network without needing to define any configurations. This is very handy. You can spin up a 5-node local network. So let me show you real quick what that looks like. Let me exit this. You can see I have Avalanche running here. Just so you guys know, if you're using Avalanche, I'm the one who's been maintaining it, and I'm going to no longer be pushing new builds. So, you know, if there's a new build of AvalancheGo, one of the things you have to do is bump the AvalancheGo dependency in Avalanche and push out a new build. I'm going to no longer be doing that. Avalanche has officially been deprecated. So if you're using it, you should take the time that it takes to figure out how to off-ramp your knowledge of Avalanche and on-ramp your knowledge of the local network runner. It allows you to interact with an AvalancheGo network using a network interface, and allows you to interact with a node using a node interface. So you can literally script networks and nodes, and you can use AvalancheGo. It's incredibly powerful. So if I say go run, for example, it's going to run this local 5-node network. It's going to create a local 5-node Avalanche network, and it's going to wait for all the nodes to become healthy. So you can see right here, it says creating a network with 5 nodes. It's then going to create these temp directories where it's going to store the logs. You can see that each node, so it created 5 nodes. You can see right here, node 0, node 1, node 2, node 3, node 4, right? So 5 nodes with 5 temp directories. And then each node has a peer-to-peer port, and then also a API port. So you can see what it's doing right now is it creates a local network, prints the names of the nodes, prints the node ID of one node. Then it starts a new node, removes one of the existing nodes, and plugs the other node in. So this kind of just gives you a sense of, yes, you can script things, you can spin up and down nodes, you can remove nodes from the network, you can put new nodes in the network. It's very, very, very powerful. And so now what it's going to do is it's going to wait for them to return healthy, and then it's going to chill until I kill it with Control-C. So now I'm going to grab one of these ports, and I'm going to jump on over here to Postman, which we'll talk about here in a second. I'm going to add this here. And now let's go to is bootstrapped, and we're going to ask the network, is the C-Chain bootstrapped? And you can see it said true. So if I go over here and look at the code snippet, this is the curl which is happening. It's going to localhost. It's hitting that port 64963, which is this one right here. And it's saying basically, is the C-Chain bootstrapped? And it's saying yes. So that all worked on a local 5-node network. And as I mentioned, you can script these in any way you like. So this is incredibly powerful. This is not like a simulator like Ganache. These are 5 actual instances of AvalancheGo. This is running a real Avalanche network on my local machine. This is actually doing real Avalanche consensus on real transactions. This is very, very, very powerful. So 1 second. Okay, so now I want to move on to the next tool, which is the, jump back over to the browser. Next, I want to talk about Postman collection. So Postman is a platform for building and using APIs, and it simplifies each step of the API lifecycle and streamlines collaboration so you can create better APIs faster. And if you are building REST APIs and you're not using Postman in your workflow, then I highly, highly suggest that you spend the time required to on-ramp your skills to Postman. Something along that vein. There is a tendency as you move forward in your career, and maybe it's just it's like an artifact of getting older or something. I haven't pinpointed it yet, but there is a tendency as people progress in their career for them to be reluctant to learn new tooling and new skills. Basically, they ossify. They believe that whatever they have is good enough. It's not worth it. They don't see the benefit of adding the new tool. I say that's a trap that you do not want to fall in, and that I suggest you just to try and maintain like this create childlike wonder with regards to always wanting to learn about the newest, coolest, most powerful way to do stuff. And the reason I feel like that is we work in a very unique field, not just in the blockchain space, but in computer science in general, where we are dealing with this phenomenon of like accelerated complexity. And so one of the things that has remained true since the beginning of computer science is that programming has always gone from programming in the low level, like machine code, to programming in the high level, like object-oriented programming, and then from programming in the small 1 or 2 files to programming in the large, right? 1 billion lines of code in the modern Windows operating system or whatever. And that same pattern keeps repeating itself. So whatever today we consider to be extremely huge and extremely high level, our kids are going to think of that as very low level and very small, because they're going to continue to experience this rapid explosion of complexity. And so in order to always be able to tame the next explosion in complexity, and in order to be really valuable as an engineer, you need to be able to always have the latest and greatest APIs. You always need to be moving your ways of thinking up, 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 bigger, 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 bigger. And so that's why you need to be not be reluctant to learn new tools, because the chances are, if you're just learning the industry best practices and you're just keeping your skills fresh, that churn in tooling that you feel is really you learning how to solve problems in a better, in a higher, and a more efficient way. And so I just always urge you to learn new tooling. So for example, if you're not using Postman, trust me, if you're building REST APIs, if you're doing gets and posts and puts and deletes and patches, if you're doing HTTP and you're returning JSON, if you're in that paradigm, and if you're a web developer, you absolutely must use Postman. Just take the time it takes to learn it. And so we have a full Postman collection. I myself maintain it. You can see it right here. There are several cool things which Postman has. It has what's known as environments. So you can see I have a local host environment file right here. And you can see I have Fuji, which is our test net, and mainnet as well. There's secrets over here. You can see my strong password or whatever. I don't care that you see these, because these are a local host environment, but I wouldn't want you to see what's in my mainnet, for example. And so you can create these variables, like I have protocol, host, and port. And then if you have collections, which are going to be groups of HTTP requests, you can then use those variables. So you can see I have this post request to protocol host port /ext/info, and I'm passing into the body info.isBootstrapped for the C-Chain. And so you can see over here, another cool thing that Postman has is called code snippets. So if I click this, it'll show me the curl request, and it'll plug in those environment variables into the variables here. So you can see it's localhost and then the port, and then I can run it, and you can see it should be 9650 anyway. Sorry, wrong port. So you can see it just ran it, and now it's saying that the C-Chain is bootstrapped. I can change the value. Okay, I don't care about the C-Chain. I want to know, is the X-Chain bootstrapped? The X-Chain is bootstrapped. Postman has documentation, so you can see at the top this little icon. I actually went through all of our docs and pasted the description into this, and if you click more info, it'll take you over to our docs and actually open the info.is bootstrapped. So that's pretty slick. Whoops, sorry. You can change the request and the response type. So don't want JSON, instead want XML. Here it is. Same thing down here. You can see the HTTP code, the amount of time, the size of the response. This is incredibly powerful. I barely touched the surface. Again, I suggest using this. You can see over here, the collection is exhaustive. It has every single one of our JSON RPC endpoints. I myself created this and I maintain this. I keep this very up to date. So this should be pretty much up to date. It might be missing one or two, or one of the two might be out of date or something, but it's very, very close. And so this is cool. Integrate this into your workflow. The next thing I wanted to mention are our docs. So our docs are also exhaustive and up to date. The repo is open source and it's in Markdown, so it's incredibly approachable. And we encourage everybody at AvaLabs, literally everybody on our team is encouraged to feel free to add to this documentation. And I want to extend the offer to everybody who's watching this presentation. In our opinion, this is a living document. And this is the canonical source of truth for our entire ecosystem. Our documentation is. And so we want to do everything we can to keep it up to date. So if you see something that's out of date, or if you want to make an improvement, please fork the repo, make the change, and create a pull request. I myself help maintain this document, and it's very likely that I would be the person to see your change and approve it or merge it. I think that updating documentation remains the single easiest way to contribute to an open source project. It's a great way to connect with the team. It's a great way to help move the project forward. It's a great way to build up social equity in that ecosystem. And I know, as somebody who's spent the bulk of my career working in open source, that documentation is just it's an evergreen problem. It's an evergreen source of work. It's never done. There's never a point where you're like, we're done. Even if you're done, then you can add examples. Even if you've added examples, then you can add localization. You know what I mean? There's just always something you can do to take your docs to the new level. And so as somebody who is maintaining, AvalancheJS or doing a bunch of other tasks, continuing to push the ball forward on the docs just requires a lot of focus and work. And so if you are trying to on-ramp into an ecosystem and you want to build social equity with a team, then go lift the burden off of their shoulders and just start working on the docs. It's the very, very, very first thing I did when I joined AvaLabs. No kidding. My very first day on the job, I just took the docs over and accepted ownership of it. And I earned the respect of Dan, the guy who was maintaining the docs pretty much solo by himself at that point. And then he, gave me co-ownership of the repo, and boom, I've been helping maintain the docs ever since. And so I suggest you do the same. Just take ownership of it. If you see documentation that could be improved, please take the time to improve it. Okay, so now we got AvalancheJS. This is the library that I've been helping to maintain since I've been on the team. This is our TypeScript library for interacting with the Avalanche platform. And because it's built with TypeScript, it supports both the client and the server. So you can do browser apps, you can do Node.js, whatever. And it allows you to issue commands to Avalanche full node APIs. So not only can you do local stuff, you can create transactions locally, you can create key pairs locally. You can also send requests to Avalanche full nodes, which is very cool. It supports the full range of JSON RPC. So it supports all of these APIs: admin, auth, AVM, EVM, health, index, info, key store, metrics, platform, virtual machine, and the sockets API for real-time data over WebSockets. And using AvalancheJS, developers are able to locally manage private keys, retrieve balances on addresses, get UTXO for addresses, build and sign local transactions, issue signed transactions to the X-Chain, the P-Chain, and the C-Chain on the primary network. You can create a subnetwork, swap AVAX and assets between the X, the P, and the C-Chain, add validators to the primary network, add delegators to the primary network, administer a full node, retrieve Avalanche network information from a node. You can even create BIP39 compliant mnemonics and you can create BIP32 and BIP44 compliant HD nodes. So the full suite of stuff is available on AvalancheJS. We have full test coverage. We use Istanbul and NYC. I think right now we've got in the 90th percentile of test coverage. The code is extremely high quality. As I mentioned earlier about when I was talking about learning new skills in Postman, the same thing is true for AvalancheJS. AvalancheJS is written in TypeScript. And if you are working on the modern web today, and I suspect somewhere in your workflow is something that has to do with the web because the web is ubiquitous, you should take the time to learn how to use AvalancheJS. To use TypeScript, I should say. TypeScript is a huge leap forward from JavaScript. JavaScript is kind of a quirky language. It just happened to take over the entire planet and become the most popular runtime in all of history, but it was created in 7 days by Brandon Ike back in the mid-90s. And so I don't think anybody who was probably at those brainstorming sessions in that week would have predicted that JavaScript is going to take over and run on everything from toasters to IoT devices to, implants in people's bodies. The web is everywhere. And JavaScript is the object-oriented language which bundles with the web. So despite its idiosyncratic nature, it's what we got, and it's unavoidable. And so we're very fortunate that we have these higher-level APIs like TypeScript, which ultimately transpile or compile down into JavaScript, which runs on all these different web platforms. And so trust me, take the time, on-ramp into TypeScript. I won't even work with JavaScript, and I don't mean that in some like I'm too good for that. No, as a professional engineer, it's my job to do the right thing, and you should not be writing value-bearing software without types. It's just a huge red flag and a code smell for me. And so learn TypeScript. Trust me, the entire world would be better off for it. We also have a wallet SDK. So the Avalanche Wallet SDK is a library for creating and managing non-custodial wallets on the Avalanche network. And it provides high-level methods to transact on Avalanche's XP and C-Chain. And so, why do we have both AvalancheJS and a wallet SDK? Because the purpose of AvalancheJS is to do the things which only Avalanche does, literally the Avalanche specific functionality. So AvalancheJS is where you go if you need to create an add subnet transaction, if you need to create an add validator transaction, and you need to serialize it down into the bits and the bytes. You can do that with AvalancheJS. For the wallet SDK, the wallet is really targeting this paradigm of DeFi and the wallet that are happening on our C-Chain, but not just our C-Chain. We also have the X-Chain wallet and the P-Chain wallet. So the wallet SDK and the AvalancheJS SDK just have two slightly different problems they're solving. AvalancheJS is really meant to be the glue code that does all the serialization and Avalanche network specific stuff. The wallet SDK is specifically to have singleton wallets. So if you only have a public and private key pair, and you don't need a mnemonic, and you don't need key path derivation, that kind of stuff, you can do singleton wallets. You can do ledger wallets. So if you want to connect your actual ledger hardware device, you can do mnemonic wallets. So as I mentioned, we can generate BIP39 compliant mnemonics and then BIP32 and BIP44 compliant HD paths, and we can derive an insane number of keys, like 2 to the 513 or something outrageous, several orders of magnitude away from every atom in the entire visible universe. You can create XPub wallets, so you can generate extended public keys and give them to a merchant, and a merchant can generate a nearly infinite number of public keys for you with zero cryptographic access to the private key pair. It's pretty rad. Developers can receive and send tokens and NFTs. They can transfer funds between chains. They can add a node to the validator set, delegate stake to a validator, create key store files from wallet instances, get the transaction history of a wallet, mint NFTs on the X-Chain, and even more than that. So check out the Wallet SDK. It's a great way to create and manage non-custodial wallets on the Avalanche network. Another thing that's really worth mentioning is that we are backwards compatible with the EVM. And so one of the reasons Avalanche has had just a meteoric rise this last year has been that our C-Chain is 100% backwards compatible with the existing EVM developer tooling in their workflows. So developers really just needed to add Avalanche as a new network for their existing workflow, and things just worked. So all of these dapps, which have spent all of this time building to launch on Ethereum or launch on the Binance Smart Chain or launch on Polygon, all of these teams simply just had to add Avalanche as a new network, and they were able to just instantly deploy to our network. And they got all of the benefits of Avalanche consensus, high throughput, fast finality, super lightweight, quiescent, etc. And so that's the reason it's been blown up, because we know the quality of the product that we're shipping is in fact as good as we say it is. And so we are extremely confident that once these teams, which have been suffering from, high network cost in these other ecosystems, as soon as they tried Avalanche, we knew they were going to be hooked. The thing about what we're trying to do is just build a network effect and get people to use it so we can further incentivize the blue chip dapps to come over, because the UX and the code, developer UX, etc., is already there. Now we just need a reason for them to see to come over. And we've accomplished that with what's known as Avalanche Rush, which is a huge incentivization program for blue chip dapps, which has been very successful. But in the context of this backward compatibility, you can see here on the screen, I've put the Avalanche mainnet settings, the Fuji testnet settings, and it says Avash, local testnet Avash, but it's no longer called Avash, but the local testnet settings. These are the values you need to add to MetaMask, to Remix, to whatever your local truffle or hard hat deployment workflow looks like. You got a JSON file or something somewhere. These are the values that you want to use. And like I said, we are 100% backwards compatible with existing Ethereum developer tooling. If you have a dApp which works on an EVM ecosystem, you can instantly deploy it to Avalanche. We have a grant program, we have a incentivization program, and we have a ecosystem infrastructure and foundation investment program on top of the funding from this ecosystem, from this hackathon. And so simply to say, there is a lot of opportunity for developers in this ecosystem if they're willing to build the tools. So you can see on the left there, Open Zeppelin, Truffle, Hardhat, Remix, MetaMask. Those are the tools that I use in my particular workflow, and they all work out of the box on Avalanche. I suspect you probably use some of those, and then you've got a few on there that you use that aren't on there. The tools that you use, if they work on Ethereum or an EVM, they should work on Avalanche. So please check them out. And if there is a bit of ecosystem infrastructure, a DeFi primitive, a cloud service, a form of smart contract, I don't know, it's, there's so much. But if there is a primitive that is missing in Avalanche and it is live today in another EVM ecosystem, like if you're a developer right now and you're like, wow, I can't believe they don't have that thing. This is your opportunity to fork that thing in the other ecosystem and just deploy it to Avalanche. And I bet you it'll work with very minor integration. And so this is a big opportunity for people to go and look what primitives are missing from the Avalanche ecosystem. Let's be the first people to launch those, because there's going to be a huge network effect and opportunity cost for the people who go first. They're going to get some buzz right out of the gate, and the people who go second are going to suffer an opportunity cost. So there is, in fact, an incentive to move real fast. As a startup, speed is your single greatest competitive advantage, and this is the moment that proves that to be true. In the context of us being backwards compatible, we have a smart contract quickstart. This was created by Connor Daly, my good friend, and the host of, I'm sorry, not the host, but the lead of our dapp squad. And I have been contributing to it as well. This is basically a GitHub repo where we are using Hardhat. You may be familiar with Truffle or Hardhat. It's a development toolkit for EVMs. We are using Hardhat with the goal of creating a guide that lays out the best practices regarding writing, testing, and deploying smart contracts on the Avalanche C-Chain. And so, as I mentioned, we use Hardhat. There are sample contracts in there that are using Open Zeppelin. So you may be familiar with Open Zeppelin. Open Zeppelin is the industry standard, as far as I know, in the EVM for battle-tested, security audited smart contracts. And if you're, doing an ERC20 or any one of the EIP derivative interfaces, 721, 1155, etc., you should be using the contracts that were released by OpenZeppelin. Like I said, they're very hardened and security audited, and we extend those and use those in this hard hat smart contract Quickstart. We have an ERC20 for just launching a regular token. We have an ERC721, so you can do NFTs. We have an example of storage, so you can write and read a very simple key value pair to and from the blockchain. And we want to flesh this out. Our intention is to add even more examples of this over time. We've just been so swamped on other stuff, it hasn't been getting a ton of focus, but it will for sure in the new year. So if you want to just fork a repo, run a command or two and have a token issued on the Avalanche network, this would be a good place to start, the smart contract quick start. I also want to talk about virtual machines and subnets. So something we won't be touching on a ton during the Moralis hackathon, because Moralis doesn't necessarily support this functionality just yet, although Ivan had mentioned an interest in it the other day. But it's still something which happens on Avalanche, so I just wanted to at least briefly touch on it, is this idea of subnets and virtual machines. So subnets allow anyone anywhere to spin up a tailor-made network with a custom virtual machines and complex validator rule sets. And the canonical example of that is our default or our primary subnet, which is live today on Avalanche, and it's the one that has the X chain, the C chain, and the P chain. And the C chain being an instance of the EVM, which is where the Moralis hackathon is happening. So the Moralis hackathon is happening on the C chain, which is happening on the primary subnet on the Avalanche network. But anybody can spin up their own subnet, and anybody can launch their own instance of the EVM or the AVM, or you can write your own custom virtual machines. And virtual machines are the application level logic of your blockchain. It's very akin to an object in object-oriented programming, where you have a class, which is like the behavior of your objects, and then you instantiate your objects into instances of that class. It's the same thing in Avalanche. You have a blueprint or the application level logic of your blockchain, and it is a virtual machine, and then you instantiate the virtual machine into instances of the blockchain. And so right now we have an EVM virtual machine, and we instantiated it into an instance of the C chain, and you can launch your own on your own subnet, and you can do that today. And we've got something called AvaSim, which is a simulator for interacting with your custom virtual machines. So if you're writing your own virtual machine, you want to use AvaSim to very quickly and efficiently interface with it. There's also a subnet EVM. We just launched this yesterday. So we've been getting a lot of requests from people who say they want to launch their own instance of the EVM. Is that possible to do? It is possible to do. We have what's known as the subnet EVM, and you can launch your own EVM instance today on Avalanche's mainnet, not just localhost or Fuji, but even on mainnet. And so, think about it. Across the world, there are a lot of teams that still launch their own layer 1 EVM instances. And we would encourage all of those teams to now just launch it on Avalanche. You can launch a subnet today and launch your own EVM, and you get out of the box Avalanche consensus, thousands of transactions per second, sub-second, immutable, irreversible finality, all of the goodies that come with Avalanche, and you'll be plugged onto our network. So you'd be able to do cross subnet asset transfers whenever that goes live in the future. So you'll be able to move the assets that are on your instance of the EVM to our C chain or to other EVMs. It's very, very, very exciting. So there's a compound network effect that comes with launching on Avalanche. We encourage everybody to look into it. We also have the timestamp VM. There's a bit of a type there. It says timestamp EVM. It should be timestamp VM. This is basically like a proof of existence type virtual machine. So you guys may have seen, it's been done several different times in the blockchain industry, like a notary public type smart contract setup, where you take a hash of a document, you write the hash to a blockchain with a timestamp, and then later, if you needed to go to court or something and prove that you had thought of an idea before someone else, you could go, look, judge, I can take a hash of that same document. I can compare the hash with the one that was stored on the blockchain 6 years ago, and it proves I was the guy that 6 years ago wrote that to the blockchain, right? It's called proof of existence. We have a timestamp virtual machine that does exactly that. So you can do this on Avalanche today. And you do exactly what I just said. Take a hash of a document or write it to the blockchain with a timestamp, and it'll create an auto-incrementing block. So it'll start stacking blocks on top of itself. And this virtual machine's GitHub repo is actually a template. So you can very quickly spin off copies of this. So you'll have the directory structure and the very basic points for making a virtual machine work. And then you can go in there and just tweak it for if you have another idea. We also have the Avalanche virtual machine, which is, of course, is the X chain on the primary subnet. This is where AVAX was first issued. You can create variable capped assets, fixed cap assets. You can create non-fungible tokens. It's got what are known as feature extensions. So you can do SecP 256K1 curve on ECDSA key pairs. You can do non-fungible tokens. You can do what are called properties, which are where you can add key value pairs to different addresses. So for example, with regards to regulatory compliance, you could say every single address that is a validator on my subnet has to be in this legal jurisdiction. They all have to meet these KYC AML requirements. They all have to have these certain hardware specifications, and they all have to have a property that proves they have a certain legal license attached to their identity. You can do that kind of stuff using feature extensions. It's very, very general and extendable. You can have a feature extension for BLS signatures or Schnorr signatures or post-quantum safe mathematics, which we already have done. We did the math on the post-quantum stuff. We just didn't pull the trigger on it yet because the NIST standards body, which is still baking that that quantum crypto algo, is not fully baked yet. So we're holding off on pushing that to production until that's ready, but it's already been done. The legwork has already been done to have post-quantum safe signatures in the Avalanche X chain, which is pretty rad. And then we also have a couple tutorials which are worth checking out. We have the create a virtual machine tutorial. So this shows you exactly how you can, once you have a subnet, you can launch a virtual machine. And then we also have the create a subnet tutorial. So this shows you how to add a validator to the default subnet, create a subnet, add validators to your new subnet, and then launch a machine. It shows how to whitelist the validators and whitelist the node on the validator. And there's a couple steps, as I mentioned, in the next big network upgrade called Blueberry. I believe we have one more last apricot upgrade. We name our network upgrades after fruits, and they're alphabetized. We're just wrapping up. I believe we have one more apricot upgrade, and then we're going to go into Blueberry. And Blueberry is going to be all about subnets and virtual machines, permissionless subnets and cross subnet asset transfers. So as I mentioned, right now you have to whitelist every node and every subnet on both ends of the relationship. That won't be the case in the future. Next, I want to talk about our public API. So there's a public API server that allows developers to access the Avalanche network without having to run a node themselves. The public API is actually several AvalancheGo nodes behind a load balancer to ensure high availability and high request throughput. The public API server is at https://api.avax.network for mainnet, and https api.avax-test.network for testnet. And to access a particular API, just to pin the relevant API point, for example, to send to the X chain, you just do api.avax.network/ext/bc/x. And you can do that for all of the different API endpoints. We have sticky sessions. Requests to the public API server API are distributed by a load balancer to an individual node. And as a result, consecutive requests may go to different nodes, and this can cause issues for some use cases. So for example, one node may think a given transaction is accepted, while for another node, the transaction is still processing. So to work around this, you can use sticky sessions, and you can do it in AvalancheJS, and this allows consecutive API calls to be routed to the same node. And with regards to availability, usage of public API nodes is free and available to everyone without any authentication or authorization. Rate limiting is present, but many of the API calls are cached and the rate limits are really quite high. So if your application is running up against the limits, please reach out to me and we can see about getting you an auth token or something like that. But we serve billions and billions of requests a month. I don't remember what the number was last month, but it's billions. It's a mind-boggling amount of requests are going through these machines. And we're not hitting any rate limit walls that I know of. I don't think we have anybody who's getting special treatment right here. But if you happen to be that dude or that team, feel free to reach out to me and we'll see what we can do. We also have a faucet. So faucets are basically to provide developers with a little bit of fun so they can test their dapps. There is actually a key. I didn't paste it here, unfortunately. We have a key called the EWOC key. It's in AvalancheJS. It has EWOQ, or the first four letters, in CB58 encoding. And it is a whale. It's pre-funded on the XC and the P chain on the local custom and local networks. So if you're doing local development, if you're using Avash right now, or if you're using the local network runner going forward, there's a key pair you can use where you have millions and millions of test AVAX on your local machine. If you're using Fuji, you want to go to our faucet and use it to get funds. And then there is no mainnet faucet. But you can, like I said, you can go to this faucet and get a drip of AVAX. You can paste in your address. And keep in mind, these are the testnet Fuji AVAX, and they have no monetary value. So don't get it twisted. We're not giving away money. This is simply if you're using Fuji and you need to some AVAX. And I think we're about to wrap it up here. We have a wallet. So this is the web wallet. If you go to wallet.avax.network, this is our web wallet. We absolutely love this thing. This has been around since before we went live on our mainnet. It has a portfolio, so you can see all of your variable and fixed cap assets. You can see NFTs. You can see assets from across different chains. You can send. So, of course, you can send on any of the primary subnet blockchains, XC or P. You can do cross-chain transfers. So, cross-chain transfers are incredibly powerful, and they're built into the protocol of Avalanche. So you can move assets between different blockchains. And, imagine the power of being able to move Bitcoin between Bitcoin and Ethereum if that were a thing that were built into the protocol. Well, it is on our network. And so using the wallet, you can, with a click of a button or two, move funds between different blockchains. Incredibly, incredibly powerful. You can also earn. So, DeFi is incredibly revolutionary. It's Web3 and DeFi are game changers. And one of the things you can do to secure the Avalanche network is you can stake or delegate tokens. So at a minimum of 25 delegated tokens, you can make the network more secure. And you can, in turn, I think, make around 10% of a return over the course of a year. And so it's a pretty foolproof DeFi strategy to simply lock up your funds and make 10% on them over the course of a year. I think that's very nice. And people don't have to be DeFi or finance wizards to understand the benefit of doing that. I've seen plenty of people's eyes light up when you tell them how simple it can be. And then there's also a studio, an NFT studio. So you can create non-fungible tokens through a GUI in the Avalanche web wallet. And then I think this might be the last slide. We have explorers. So if you've ever dealt with the blockchain, you know that there are going to be blocks, there are addresses, there are transactions, there are sort of these primitives, and then you need some piece of software which traverses this blockchain and is able to show you all the important information. And these are called block explorers. I think block explorers are fun. It's a fun thing. I have always found that I think block explorers are a good way to on-ramp a new developer into an ecosystem. I myself have built maybe 3 or 4 in my career. Whenever I'm learning a new blockchain technology stack, I will often just write a little basic explorer to better understand how to traverse the blockchain and pull out the addresses and figure out the inputs and the outputs. It's just everything that has to do with this entire stack is going to be represented in this explorer. So it's just a really great way to have an exhaustive experience teasing out every single bit of information that has to do with the blockchain. It's pretty rad. And so we have a couple. We have snowtrace.io, which is actually built and maintained by the folks that do Etherscan. Etherscan is like the biggest Ethereum block explorer, and I don't know if it's through a grant. I'm not sure what the nature of the relationship is, but they write and maintain Snowtrace, which is an Avalanche C-Chain block explorer. It's very, very, very high quality if you've not checked it out. And then we also have the explorer.avax.network, which is built internally by our amazing team and also really, really good. But it focuses on the P chain and the X chain. It might do some lightweight C chain stuff, but it's primarily P and X. And so you can imagine as more and more of these blockchain networks take off on Avalanche, we're going to see more and more of these different types of explorers because there's going to be more and more different blockchains. So it's a very exciting and interesting field. And like I mentioned, I think explorers are a great way for developers to on-ramp into a new to a new blockchain ecosystem, because every single thing that has to do with the blockchain is going to be on that explorer. And so if you're trying to figure out how it all works, well, then write an explorer and you will know how everything works. And then, I just wanted to maybe give a couple shout outs to our ecosystem partners. We have Avascan, which is awesome. They're also another block explorer. They used to have a GraphQL API. I don't know if they still do, but they also have some developer tooling. And then we have VS Scout, which is another cool local team. And then I wanted to mention this, even though there's a ton of funding in this project, there's also other funding mechanisms in the Avalanche ecosystem. So I just wanted to express that there's a lot of opportunity for developers out there. Thank you so much. If you made it this far, my name is Gabriel Cardona, developer evangelist at Avalabs. You're an absolute champion. You can reach me at CG Cardona on Twitter. You can reach out to me on Telegram. I get a ton of inbound messages. So if you message me and I don't immediately reply, please bear with me. But I really do try and reach out to everybody. It's a great honor to meet all the amazing and smart, creative people that I do every day. So thank you very much. Again, I want to give a shout out to the Avalabs folks. Thank you, love and respect. And then I want to give a shout out to the Moralis folks. Thank you, Ivan. Thank you, Birdie. Thank you, Rasmus. Thank you, the entire team. You guys are great. Thank you for everything you do for the blockchain space. And that is it. Cheers, y'all.